Okay guys, so in front of me on my screen right now, I am looking at Form A of the quiz that you took yesterday. So if you have Form A, you get to follow along in order. If you don't have Form A, you should be looking at the PDF of the questions so that you can find this question on your paper. So again, if you're logged into ZipGrade Student Portal and you are still looking at a photograph of your answer document, you need to click those words View Questions so that you can actually see the questions and follow along. Guys, I am going to strongly encourage that you maybe take some notes down as we go over this today. That's always the case, but if you missed something on the quiz, obviously I don't think either of us want you missing the same thing on the test. So make whatever notes you need to make so that you don't make the same mistakes tomorrow. Again, this is Form A, number 1. If you don't have Form A, please look for this diagram. And we're going to go over the 2 questions underneath it. It says, use the schematic below to answer the questions that follow. Which of the following would be the reading for the ammeter A6? So that ammeter that it's referring to at A6 is right here. Okay, and so an ammeter measures current. This is a parallel circuit. It has 3 resistors, each of them on their own loop. So it's not combination, it's parallel. But what we want to do anytime we have a parallel or a combination circuit is to color code those loops, because it can be helpful so that you can visualize and see what's going on. So some of the charges in this circuit are going to follow this pathway right here. Okay, those particular charges do not go through my ammeter at A6. So I know that I'm not looking for the total current. If I trace the other 2 pathways, because again I have a total of 3 loops, some of my charges are going to follow this path. Those charges do go through A6. And then the rest of my charges follow this path, and those charges also go through A6. So A6 has both the purple and the blue going through it, which means if I want to determine what the reading would be, I need to figure out how much current flows along this blue loop and how much current flows along this purple loop and add them together. Alternatively, I could find the total current of the circuit and subtract this yellow loop. That's another way to get to the same answer, because all of the current goes through here except for the yellow part. Okay, I'm not going to do it that way, although it is an okay way to do it. I'm just going to go ahead and solve for the current through here and here and add them together. Okay, now I know that I can get current using Ohm's law if I know voltage and resistance, because I know that I have this equation. And so I can use this equation to find the current through this loop and to find the current through this loop and then add them together. Okay, I can see the resistances, they're labeled in the picture. What I don't see labeled on each loop is the voltage drop. So let's go over that real quick, because we have a rule, one of Kirchhoff's laws, the loop rule, stated that the voltage drops along a loop add up to the voltage of the battery. I have 3 loops. I color-coded them. Each of those loops only has 1 voltage drop. And so the voltage drop here, guess what? It's 20 volts, because along that loop adds up to the battery. There's only 1. This one, also 20 volts. It's the only one on that loop. This one, also 20 volts. Okay, so my voltage drops in a parallel circuit are always equal to each other. And in a parallel circuit, they're also going to be equal to the battery, because, again, each of them is on its own loop. And so now I have the voltage drop and the resistance at both R2 and R3. So I can use Ohm's law now to solve for the current here and the current here and then add them together. So I'm going to start with this blue loop. I'm going to say that my voltage drop 20 equals I times my resistance here is 5. And so I can tell that my current is going to be 4 amps. 20 divided by 5 is 4. But again, that's only through the blue loop. Now I have to do the same thing for the purple one. Again, V equals I times R. My voltage drop here is also 20. My resistance here is 8. And so my current here will be equal to 20 divided by 8. So again, we're going to put this one in the calculator, or you might be able to do that in your head. But 20 divided by 8 is 2.5. Okay, so my current through the purple loop is 2.5 amps. So now I know how much of it goes through the blue loop. I know how much of it goes through the purple loop. I can add them together because they're both going through this ammeter. Okay, so 4 plus 2.5 is 6.5. The answer to this first question on Form A is answer choice C, and 80% of you got it correct. Those of you that missed it, largely put this 4 amps, which is what you would have for just this one loop, but it's not just the one, it's both of them. Again, if you color code it, you can see that. So I'm going to strongly encourage that you do this on your test. Just sketch it back out on your paper real quick. Okay, it's 3 rectangles. Doesn't take that long. You don't have to draw it pretty. Okay, just draw it so that you can see what goes through that point. Questions about number 1? All right, number 2 also goes with the same diagram. And number 2 says, what is the power dissipated across R1? I do have an equation for power. Power is equal to voltage times current. And if I look at R1, I know the voltage across R1, my voltage drop is 20 volts. But what I don't know is the current through R1. However, I can find the current here exactly the same way that I found it in the other 2 loops. So if I find that current, then I can go ahead and solve for my power. But that means that it's going to take me 2 steps. I'm going to have to use Ohm's law first. I know my voltage there is 20, and it's equal to current times my resistance here is 10. And so my current is going to end up being 2 amps. Okay, this is not my answer to the question, by the way. It is a choice. It's A is a choice, 2 watts. That's not the answer, though. Nobody put it in here, so that's good. But this is the first step in finding my answer. So now that I know the current, I can use it over here. Power equals my voltage. Again, my voltage drop is 20. My current is 2. 20 times 2 is 40. The answer to number 2 should be D. Questions about number 2 or about either of the first 2 questions? No? Okay, again, guys, remember, you have a test tomorrow, so if you're not sure about something, please speak up so that you don't miss the same type of question tomorrow. And again, you should be jotting some stuff down, especially if it's something that you missed, so that you don't miss it tomorrow. Number 3 on Form A goes along with this picture. So again, if you do not have Form A, you need to go ahead and find that diagram on your paper. It says the circuit below contains 3 resistors, R1 through R3. The current is greatest through which of the resistors? Okay, and so we have 3 of them here. This, by the way, is a combination circuit, and I know that because I have this parallel section that is in series with this. And so I have both series and parallel connections, so I do need to analyze it as a combination circuit. And anytime I have a combination circuit or a parallel circuit, again, I'm going to recommend that you color code those loops. So I know that some of my charges are going to do this. And I know that the rest of my charges are going to be on this pathway. Again, there are 2 loops here as these charges move around this circuit. Okay, blue and purple, or whatever colors you have. I don't have to do any math to answer this question. Now, could you? Sure. It's a lot of math, though. Okay, we don't need the math. The question is, where's the current the greatest? And if you look at this, this has part of the current. This has part of the current. This has all of the current flowing through it. Both the purple and the blue go through R3. This has the most current because it has the total current flowing through it. So the answer to this question is C. Okay, now I didn't ask you to do this, but I could have asked you to rank them. So let's go ahead and do that, even though it's not in the question. I have my greatest resistance through R3. It splits here. It doesn't split in half, though. If these had the same resistance, if it was 5 and 5, it would split in half. It's not. Okay, so they're not going to be the same, but it is going to split. Now, when you have a parallel circuit or a parallel section on a combination circuit, there was a rule that we used to figure out where most of the charge is going to flow, or where more of it's going to flow. And we said that that would be the path of least resistance. So if I were ranking them, this one's still going to be the most because these are both only part. But when you compare these two parts, this has less resistance than this. So R1 would be next, and then R2 would have the least amount of current flowing through it, if I asked you to rank them. Okay, and I wanted to go over that just in case, but the other reason I wanted to mention it is because those of you who missed this question largely put R1. And so maybe you were thinking path of least resistance. Okay, and that's not a bad thought, but this is a combination circuit. So you need to also keep in mind that this is, even though it's the path of least resistance, even though it is going to have more current than this, it still doesn't have the total. Okay, and so this is going to have the most current flowing through it. And then this, if you were ranking them. Are there any questions still about number 3? No? Okay. Then let's go ahead and take a look at the next question. Number 4 on Form A goes along with these diagrams. So again, if you have Form A, it's number 4, but otherwise you need to find that question with those diagrams, and let's go ahead and take a look at it. All right, it says identical resistors are connected across the same 12-volt battery. Which circuit has the greatest equivalent resistance? So I have here a simple circuit, a series circuit, and 2 parallel circuits. Okay, I know that the voltage drops along a loop add up to the battery's voltage. Okay, but here I'm ranking them by resistance. Okay, I know that I calculate the equivalent resistance differently in a series circuit than in a parallel circuit. I know that in a series circuit, I simply add them together because they're all on the same loop. And so my resistance here would just be R. It does say that R is all the same, so if you want, you could pick a number, and you could actually solve for each of these. We could say, okay, let's pretend that R equals 2. Why not? And you could calculate it. That would mean that this has a total resistance of 2. This one would be 2, 4, 6. Okay, you add them together. However, when you add them in parallel, we had a different equation. 1 over RT equals 1 over R1 plus 1 over R2. If I'm pretending that these are 2, okay, then I would end up 2 over 2, which if I flip it is still 2 over 2, which gives me an equivalent resistance of 1. Remember, when you add your resistors in parallel, you don't have to do the math, by the way. When you add resistors in parallel, your equivalent resistance goes down, because now I have 2 pathways, and the charges still only have to go through 1 resistor, but now they have 2 different pathways to do it on. So my resistance, if I'm pretending that these are both 2, my total is less than either of them individually. Same thing here. This would end up being 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2. That's 4 over 2. And if I flip that, 2 over 4, which makes the equivalent resistance here 0.5. Again, my resistance goes down when I add more resistors in parallel, but it goes up when I add them in series. And so you can tell, and I again didn't have to do the math, I can see 4 pathways. I know this has the least resistance. I can see 2 pathways. I know that's going to be next. And then this is going to be next, and then this, because this has multiple resistors all in the same pathway. Okay, so you should have been able to get there without math, but if you want to, if you're stuck, plug in some fake numbers. If it tells you they're all the same, pick a number and just pretend that they're all that number and then compare them. Okay, so again, the greatest equivalent resistance is going to be this one, my series circuit that contains 3 resistors. That's answer choice B. Even though this one has 4 resistors, it does not have more resistance. It has the least resistance because they're connected in parallel. That's 4 pathways. Okay, so number 4 should be B. Only one person missed that question, so you guys did really good with that one. Questions about number 4? All right. Number 5. Number 5 says the schematic shows 3 identical light bulbs connected in parallel, which would result in an increase in the brightness of bulb 1. And we've got some different statements here. Removing bulb 2 from the circuit, replacing the filament in bulb 1 with a thicker wire, halving the voltage of the battery so that you have half the voltage in all of these. I'm actually going to start with the third statement first. What would happen if we had half the voltage from the battery? Well, if you have half the voltage from the battery, again, we can see the relationship between the variables in Ohm's law. If I have half as much voltage, and my resistance is going to be what it is here, okay? Whenever I have half the voltage of the battery, I'm going to have less current because the voltage and the current are going to be directly proportional to each other. Okay, and less current is not going to make things brighter. Okay, it's going to actually do the opposite. If I have a smaller battery, they're going to be dimmer. That makes sense. Okay, and so we don't want to pick C. Okay, because that's not going to make it brighter. It's going to give us half the amount of current, and that's going to make us have half the amount of power, and that's going to make things dimmer. Okay, so we don't want to pick that. By the way, because I know C is incorrect, that means it can't be D either. It can't be all of these if C is wrong, which means I already have eliminated it, and I have a 50-50 shot now between A and B. Okay, A, looking at it to begin with, I'm like, A is a little bit tricky. Okay, I'm not entirely sure, so let's focus on B first. Okay, B says, replacing the filament in bulb 1 with a thicker wire. We talked about factors that affect the resistance in a circuit, and thickness was one of them. When you have a thicker wire, think of it like a wider roadway. Okay, do you have more or less resistance? More or less traffic if you have more lanes, a wider roadway. Sorry? You're going to have less traffic. You're going to have less resistance also. Again, ultimately, resistance comes back to collisions because electrons aren't like cars. They're not steering their way through there. They are literally pinballing their way and bouncing off of things as they move through the circuit. Okay, and so wherever you have fewer collisions, you're going to have less resistance. And if you think of that wider hallway, that analogy, you're going to collide with less stuff when there's more space for you to move through. Okay, and so this right here means less resistance. Okay, and if I have less resistance in bulb 1, which is what it says because it says bulb 1, then again, I know that charges prefer the path of least resistance. I'm going to have more current. So less resistance is going to mean more current. And more current is going to mean more power and a brighter bulb, which means this is a true statement. Okay, brightness of bulb 1 will increase if we have less resistance, or a thicker wire would do that. Okay, and so the answer to this question is B. Now, A was the one that some people were asking questions about last period. Now, B has to be true, so that means A can't be true. Okay, because again, B, we know B has to be true. But if you were to remove bulb 2 from the circuit, okay, if you remove this from the circuit, your total equivalent resistance of the circuit increases because now you only have 2 pathways instead of 3. But it actually ends up being that each branch still has the same current that it had before. And they each still have the same equivalent, they each both still have the same voltage drop as well because it's a parallel circuit. The brightness actually stays exactly the same. It doesn't change. You can prove it mathematically, or something that I'm going to recommend that you guys take a look at again, especially if you're having trouble with some of these concept questions, is this FET that we did previously. We used this, and I actually built the circuit. So I have 3 bulbs here. Oops, sorry. I lost it. I have my 3 bulbs, and I have my battery. And I'm going to show you, I added a switch here so that I could remove one of these bulbs and look at the brightness of the other 2. So if I open the switch, I want you to look at the brightness because it doesn't change. In fact, if you watch the electrons flowing through, their speed doesn't change either, okay, because the total current in each of those branches remains the same whenever you do this. And the brightness is also remaining the same. So again, if you remove one bulb from your parallel circuit, the other 2 do remain lit, okay, but they remain lit with the same brightness that they had before. So if you're not sure about something, you can actually test it in the FET. And that's true as well if you're working through any questions in your problem sets. Maybe you didn't finish all of those yet. That's true for some of you, by the way. I would definitely recommend looking back at them. But you can test it there, or you can work it out mathematically and look at what happens as well. But in either case, this right here, removing bulb 2 from the circuit, does not increase the power of bulb 1, and therefore it does not increase the brightness either. Okay? So the answer again was B. Are there any questions about number 5? Let's see how you guys did on number 5. That was probably your most missed question. Okay, you guys struggled with it. About half of you missed it. And of those of you who missed it, a lot of you did put answer choice A. Not everybody, but a lot of you. Okay, so if you still have a question, please make sure that you're asking. The bulbs do still stay lit, but they actually maintain the same brightness that they had before. All right, this is number 6 on Form A. So again, you're looking for the question with these diagrams. It says, if the bulbs are identical, in which circuit would the voltage drop across each bulb be 4 volts? This goes back to Kirchhoff's loop rule. The voltage drops along a loop add up to the battery's voltage. Okay, so like this one, let's start with C. If this is 2 volts and I have 2 bulbs, well, guess what? These voltage drops are 1 and 1. They add up to 2. Okay, this one has all 3 on the same loop. They have to add up to 12. If they're all the same, we're going to do 12 divided by 3. Well, guess what? That's our answer. That's 4, 4, and 4. And so the answer to this is A. But I do want to talk real quick about, I mean, it's not going to be B, because these are going to have to add up to 4. That's going to make this 1 1/3, 1 1/3, 1 1/3. But D. Some of you might have gotten thrown off by D because D also has 3 light bulbs connected to a 12-volt battery. However, these bulbs are connected in parallel. And again, the law says the voltage drops along a loop. Well, guess what? This loop has only 1 bulb, so its voltage drop is 12. This loop has only 1 bulb, so its voltage drop is 12. This loop has only 1 bulb, so its voltage drop is 12. Again, in a parallel circuit, your voltage drops are all equal to the battery and equal to each other because each of them's on its own loop. So you don't treat it the same way here. These are 3 of them on the same loop. They add up to the battery. The answer to number 6 is A, that series circuit with 3 bulbs in it and a 12-volt battery. Questions about number 6? Those of you who missed number 6 largely put this. Most of you who got it wrong put this one. The voltage drops along a loop add up to the battery. Remember that rule, right? Yeah. Okay. So here's a loop. How many voltage drops happen on that loop? 1. So if they have to add up to the battery, but there's only 1 of them, it has to equal the battery. There's nothing to add. There's another loop here.
So they're all, the voltage drops are the same in parallel, but also the same in series?
Well, yeah, in this case, they're going to be the same because it says the bulbs are identical.
Oh.
They're not always the same in series like this. It's only because this particular question said the bulbs were identical. Any other questions? I think we cleared that one up. No? Okay. Again, guys, please ask the questions if you have them. Please ask so that we don't make the same mistakes tomorrow. All right, this is number 7 on Form A. You are looking for these diagrams which show a voltmeter connected to a series circuit. And number 7 says, which voltmeter reading would give the greatest reading of electric potential difference or voltage? Again, voltmeters are connected outside the circuit in parallel, and that's true for all of these. You can see it's just an extra branch. It almost looks like another loop. It is another loop on the circuit. And when you connect the voltmeter like this one, for example, it measures the change in electric potential energy that the charges have between these 2 points. It's measuring what happens in between it. So this one is measuring however much change happens here. And you will have an energy change if you have a resistor or a battery. Okay, you're going to have an energy loss from your circuit here. That's why we call it a voltage drop, because you're losing energy. And if you connect it across a battery, you would have a gain. Okay, because the battery adds energy and does work on those charges. But this one is measuring the voltage drop just of R1. This one is measuring just the wire, and the wires are considered to have no resistance at all, which means this would have no voltage drop. It would give you a reading of 0. Okay, if you test just a wire, you're going to get 0. It needs to be connected across things like resistors or batteries. This would give you the voltage drop just here. That one's just here. This one, though, gives you both of them. Okay, you're going to have a greater voltage drop where you have more resistance. Okay, so if you have a greater resistance, you will have a greater voltage drop. I don't have to do any math. I could, but I don't need to. I know that if I measure both of them together, that's going to be a bigger voltage drop than them separately. And so the biggest voltage drop is going to be here at answer choice D, because I'm measuring both of them together. This is only going to be part of the total voltage drop. This is only going to be part of that total voltage. This right here is going to be 3 volts because the voltage drops along the loop add up to the battery. This is the whole 3 volts. Okay, and so that's going to be my greatest reading. For number 7 is D. Are there any questions about number 7? You guys did okay on that one. About 80% of you got it right. All right, let's take a look at number 8. Number 8 has these 2 diagrams, and it says circuit A and B are identical, except that circuit A has 2 1.5 volt batteries, whereas circuit B only has one 1.5 volt battery. Which of these statements is true regarding these circuits? So everything is identical except for the battery's voltage. This one basically has twice the voltage of this one. 2V versus V. Or you can call it 3 versus 1.5 because it actually does give you numbers. Okay, and so let's read the statements. Statement 1 says circuit A has twice the resistance of circuit B. Resistance is not determined by the batteries. Resistance is determined by the light bulbs or resistors that are connected to the battery. And these both only have one light bulb, and that light bulb is the same. It says identical, which means the resistance here and the resistance here are equal. They both have the same resistance, whatever it is. Maybe it's 2 ohms. I don't know. Pick a number. Okay, but they're the same, which means statement 1 can't be true because the resistance isn't determined by the batteries. It's determined by the light bulbs. And if I look at my answer choices, because I've eliminated statement 1, that means I can't pick A, I can't pick B, and I can't pick E. So I have already narrowed my choices down to just C and D, which means I know that statement 3 has to be true because it's in both of them. The question is 4 also true? Let's read 2, though. We know 2 can't be right because it's not in our choices, but let's go over it real quick. 2 says circuit A creates twice the charges that then flow through the circuit. Guys, that is one of the really common misconceptions. Batteries do not make the charges. Okay, so just because I have 2 batteries doesn't mean I have 2 times the charges. Okay, it does provide the push to move them. I do have twice the voltage. I have twice the push on those batteries, and I'm going to end up with twice the current. It's going to flow a greater rate of flow. Okay, but I'm not going to have twice the charges because the battery doesn't make the charges. So we already know 2 couldn't be right because it's not in my choices. Again, the question is 4 correct or not? So let's read the last statement. The flow of charge in circuit A is twice the rate of circuit B. And guys, this term, these words right here, flow of charge, that is the definition of current. And so this question is saying the current in circuit A is twice the rate of circuit B. And look at this relationship. Again, Ohm's law describes this relationship. Okay, again, both of these circuits have the same resistance. If you were to double the voltage, which is exactly what we did in circuit A, we have double the voltage. If you double the voltage, the current also has to be double. They're directly proportional to each other. If the resistor stays the same, which it does, then when you double this, this also doubles, which means you do have more current in circuit A because you also have more voltage in circuit A, which means the answer is D. Both statement 3 and statement 4 are correct. Okay, so again, when you double your battery voltage, you will get double the current if you leave the resistors the same. Are there any questions about number 8? 80% of you got number 8 right, and those of you who missed it largely chose C, which means you were on the right track. You just didn't pick statement 4 as well. Are we okay with statement 4? Do you understand what it's talking about? We're good? All right. Let's go ahead then and take a look at the next question. Question number 9 on Form A looks like this. So again, find that diagram on your paper. It says, if all bulbs and power sources shown are identical, which circuit contains only 2 lit bulbs? And guys, y'all did the same thing my last class did. Every single person got it right. So nobody missed this in my first 2 classes. I didn't look at 4th yet. But again, that just means y'all did well with it. You have 2 loops here. These are all combination circuits technically. But if you trace those loops, this one right here, you're going to have 2 bulbs lit because the switch is closed. Both of these will light, but this one won't because the switch is open. So that loop is not complete. This one's going to have 0 lit bulbs because all the switches are open. This one would have only 1 bulb lit. Those 2 aren't going to light with that switch open. And this one would have all 3 bulbs lit. And so the only one that lights only 2 bulbs is answer choice A. And like I said, everybody got that one right. So good job with number 9. But just in case, does anybody have a question about this? Okay. Number 10. All right. Number 10 says, the greater the power rating of a light bulb. And we've got some statements here that finish this sentence. And guys, I have put this on the screen at least 6 times. I've said it more than that. And I'm glad because only one person missed it. I wish everybody got it right, but write it down if you need to. The greater the power rating of a light bulb, the brighter the bulb. Power determines brightness has been on my screen so many times. Okay, and so that's going to be the answer you want. The greater the power rating, the brighter the bulb. Okay, answer choice A. I don't even have to read the rest of them because I know it has to be A. C is exactly wrong, by the way. All right. Number 11, rank the following circuits from greatest to least current flow. I only have 2 circuits here, X and Y. Basically, I want to know which one has more current. A says X is greater, B says Y is greater, and C says they're the same. Okay, so that's the question. Which of those is true? These are both series circuits. Well, this one's series. This one only has 1 resistor. My total resistance in series, I find it by adding those resistors together. So this one has a total resistance of 24 ohms. This one has a total resistance of 12 ohms. And so that's the only difference, is the fact that I have twice as much resistance here than here. And so that's what it's asking about, is how that affects current, because everything else is the same. It's the same battery. It's just the resistance that's changing. And you guys tested this in the FET and in your RA. But if you need to write it down, write it down. Again, you can see the relationship between the variables here if you don't remember testing it. Look at Ohm's law. I know it's not a math question, but it still shows the relationship. These both have the same voltage. So if you keep this the same, but you double this, this is going to be half as much. These are going to be inversely proportional. When one of them goes up, the other is going to go down. And so if you have twice as much resistance, you're going to have half as much current. Or if you have half as much resistance, you're going to have twice as much current, whichever way you want to think about that. The point is, circuit X will have more current than circuit Y, which is answer choice A, and it has more current because it has less resistance. Again, if you need to make a note of it, current and resistance are inversely proportional to one another. If you're asked a question about that, if I double the resistance, what happens to the current? Something like that. You get those types of questions a lot. Okay, or a question that looks like this. I could ask you one like this again. You should be able to answer it. All right, and again, it's A. About 80% of you got that one right. At least nobody put D, because there wasn't a D. But last period, somebody put D. So make sure you're bubbling carefully. All right, number 12. What is the resistance of a typical 1800 watt hair dryer plugged into a 120 volt outlet in your home? We have been given a power value. Watts is the unit for power, and of course a voltage. So I have power and I have voltage. And I have a power equation. P equals V times I. But this equation doesn't allow me to solve for resistance. It allows me instead to solve for current. Which means if I use my power equation to find current, I'm not done. I still have another step, and I can do that other step using Ohm's law. V equals I times R. There I can find the resistance. So this is a two-step problem. We're going to use the power equation to find current, and then we're going to use the current to find resistance. So my power, 1800, equals my voltage, 120, times I. If I want to solve for I need to do 1800 divided by 120, which is 15. This is not my answer. I am not done, but 4 of you put this anyway. Okay? You put 15 as your answer. You picked C, some of you. 85% of you got this right, but a few of you did this. You're not done yet. Pay attention to what variable you're solving for. I just found I. I need to find R. Okay, so we're going to take this number, we're going to use it over here. I still have the same voltage, 120. My current is 15, and I'm looking for R. I'm going to divide both sides by 15, and then 120 divided by 15 is 8, which is answer choice A for number 12. Again, like I said, 85% of you got this one right. Questions about number 12? All right, we're almost done. 2 left. Here is number 13. Number 13 says, what is the current through the 10 ohm resistor in the circuit schematic pictured below? So this is a series circuit with 3 resistors, and it wants to know what the current is in my circuit in this 10 ohm resistor. And guys, just as a quick reminder, in a series circuit, I could measure the current here, or here, or here, or pick a point. All of those are going to have the same current because there's only one loop. There's no splitting of charges. Okay, so again, remember, in a series circuit, your current is the same everywhere. This is a series circuit. My current is the same everywhere. It'll be the same in the 10 ohm resistor as it is leaving the battery, as it is right here, as any point. Pick a point. Okay, and some of you forgot that because due to this right here, if I want to figure out what that current is, I have to go back to Ohm's law, but I have to use the total resistance of the whole circuit and the total battery's voltage to find it, because that resistance depends on the total resistance of the circuit. The current depends on that. So whenever I go to solve this, I know my battery's voltage is 24 volts, but I don't just get to use 10. Even though the question's asking about the 10 ohm resistor, that's not the resistance I use, because that's not the total resistance of the circuit. You have to use the total. Those of you who missed it probably put A for number 13. Okay, and I just looked, you did. Okay, my total resistance has to go here. This is always how you do a series circuit, by the way. If you need to make a note, make a note. But my total resistance, 5 plus 2 is 7, plus 10 is 17. So now I can solve for my total current, and that total current is the same everywhere. So 24 divided by 17 is going to give me an answer of 1.41176, and it keeps going. But the answer is 1.4 amps. It is answer choice C for number 13. Questions about this problem? All right, one left. Last one. And you guys did really good on this, which I'm glad. My last class had more trouble. But it says, a lab group took measurements of current and voltage for a parallel circuit during a physics lab. Their setup for these measurements is pictured below. What tool is represented by number 2, and what is it measuring? So first of all, this is a parallel circuit, and my circuit is right here. Okay, part of my charges go here. The rest of my charges go here, but this is my circuit. These other wires that you see around 4 and 3, those are part of the way that you're using the device. Okay, this particular device that you see represented by numbers 3 and 4 is connected in parallel, which makes it a voltmeter. Okay, but the question's not asking about 3 or 4, it's asking about number 2. Number 2 is connected in series. It is on the wire. It is part of the circuit and the current flows through it. That is the way that you connect an ammeter. Okay, so these two would be how you connect a voltmeter, 3 and 4. But 1 and 2, that is how you connect an ammeter, and an ammeter measures current. And so the answer to this is an ammeter measuring current, which is answer choice C, and only one person missed that. Are there any questions about number 14? Any questions about anything on this quiz? We need to go back and look at anything again. No? All right, guys, then what I'm going to suggest that you do is that as you're preparing for your test tomorrow, because you do have a test tomorrow, use that unit summary. The unit summary has additional practice, or if you didn't finish your problem sets, go back and finish your problem sets, even if it's in practice mode. You can't expect, maybe you're doing okay right now in here, but you cannot expect to continuously not complete the practice problems and still do well on the test. Most of the people that got failing grades on the quiz did not complete all of their problem sets. Some of them didn't do any of the problem set, like 1 or 2 people. Okay, so if you haven't done the practice problems, please do them. I'm not giving them to you just for busy work. I'm giving them to you because you need the practice. That's how you get better at it so that you do well on the test. So if you haven't done that practice, you're running out of time. You need to do it on time next time, but do it before the test tomorrow. Okay, so problem sets, unit summary, use those things to help you prepare because you do have a test tomorrow. And we obviously want to make sure that you do good on it. You guys did really good on the quiz, but obviously test, we want to do good on that as well. That's obviously a more important grade. So if you have questions about anything, let me know. You guys have about 7 minutes left, so if you want to open up the unit summary and try some of it, or those problem sets, or if you have a question about something specific, please ask before you leave today.